Line 2 notes. So here we're doing proportions. So this is going to be write-ups all with proportions. 9.3 will be all with means. All right, so the conditions, again, these conditions, these are not changing. The only thing that's going to be a little bit different is this is going to be P sub 0, which is also called P naught. When you do this, you're not going to really concern yourself about the actual letters, because never, ever, ever write the actual variables down. They're going to give you a value for P naught, and whether it's P naught or P hat, you're not going to get all three of them in a problem. So just use the one they give you. All right, the next thing, and again, I'm not going to really talk about those. We've already talked about those so much. All right, what is the test statistic? Now, this is basically a z-score formula. It's given in general format, so you can use it for T also. I would also like to point out where it is on the formula card. It's right here. So on the front of the formula card, you got these three boxes. It's on the top box. The standardized test statistic, the z-score, is the statistic, what happened in the sample minus the population parameter divided by the standard error of the statistic. And then the standard error of the statistic is on the back. There's one for a proportions problem. There's ones for a means problem. And you're not going to be able to use a formula card to teach yourself anything, but you can use it to make it so you don't have to memorize all this stuff. But anyway, there's that. We've used that quite a bit. All right, the 4 steps, it's still state, plan, do, conclude. However, the steps have different things in them. And here's a list of them. I'll kind of talk through them actually as we go through the problem. And then again, this is the formula with variables. It's not on the formula card. I already showed you what is. That's what you need to know. And again, this looks complicated. It's really not. Plus, the calculator is going to do it all for us anyway. So we really kind of get away without knowing that. If you're like, well, why do we even see it if the calculator does it for us? So it's multiple choice picking out of the lineup questions. It'll say, which one of these is filled in correctly? But it'll give you all numbers, no variables. And then also one more thing for the inference method step for the plan right here. So when we put in the method, the inference method, one sample Z and P, right? Because it's a proportions, but now it's a test, not an interval. Interval is confidence interval. Hypothesis test, they say test. All right, what happens if the data does not support the alternate hypothesis? That's H sub A, that's the alternate hypothesis. So we need to say we fail to reject the null hypothesis. Never say except. It never says count everything wrong if you say accept the null hypothesis. Really, you don't accept anything. Don't put the word accept. We reject the null or we fail to reject the null. We do not accept it. And I will have no issues taking off full credit. College Board, again, they don't say they do, but I guarantee you if a grader, again, this is going to be somebody that's taught stats for a while, probably pretty picky. You say something like that, they're going to tag you big time for that. All right, so here we go. This is my favorite all-time question in AP Stats. I find this hilarious. But I'm going to go ahead and read this out. So, according to the article in the San Gabriel Valley Tribune, most people are kissing the right way. According to the study, the majority of couples prefer to tilt their heads to the right when kissing. In the study, a researcher observed a random sample of 124 kissing couples, and that's my favorite part. That seems insanely creepy. Like, so if you're with your boyfriend or girlfriend at a park, and you're kissing and you see some guy in a lab coat watching you and writing down on a clipboard, maybe he's just doing an experiment. But if I were you, I would get out of that park as immediately and as quickly as possible. All right, so anyway, but I find that hilarious. So we definitely include that. But 83 of the 124 couples tilted their head to the right. So there's the information. So we're going to state the parameter of interest, which is P for a proportions problem, mu when it's a means problem. No P hat here. Never do that. They'll take off for that. It's the true population proportion. And again, the word population is good. True and proportion is not up for negotiation. You must use those two words of couples who kiss the right way. And again, I just find that so funny. All right, so here we go. The null hypothesis is that there is no preference, that it's 50-50, okay? The alternate hypothesis is that P is greater than 50 because we think most of them prefer, or more people prefer, to tilt their heads to the right. And then we set alpha at 5%. There's 3 components to this problem. The first mistake, half. Second mistake, full wrong. Make that very, very, very clear. If you make any mistake in any part of these, you get half. If you make 2 mistakes, it's wrong. Also, make sure the null is always equal. The alternate will always be an inequality. Greater than, less than, or not equal to. All right, so then the plan step, a 1 sample z-test for p. Again, I get half credit for that one line, half credit for the 3 conditions. So on my conditions, the random 10% rule and the large counts, random sample of kissing couples observed, and it said it right in the problem. The 10% rule, now this is one of those where you'd say, wait a minute, are there really 1,240 couples kissing in this park right now? Well, there's nothing said that it was observed over one day or how they did it. And again, remember, we're not proving anything. The 10% rule is we're saying this must be true for the rest of this to work. And again, this one requires a little more of a leap of faith. When we said there's more than 360 Oreos on the planet, yeah, that's easy. Kroger has probably 1,000 Oreos, so 360 for the world is easy. But this one's a little bit harder. But again, don't think about it, just do it. That's not very good life advice, but that's how it's going to work for this 10% rule. All right, and then I show my work, and then I need to expect at least 10 successes and 10 failures. Not what I observed. It's not 83 and 124 minus 83. It's the expected for the test. That's a little tricky because it's very similar, yet it's also different, so be careful. Both of those are greater than 10. And I'm going to show you just in a second how we get this on the calculator, but let's just go ahead. There's that, and we'll get that in a minute. So then right here, the p-value is really small. So they're saying that if in fact it truly is 50-50, the probability that we got 83 out of 124 or more than 83, because that would be further away from the 50%, a more extreme case, further away from what the null hypothesis is saying, there's only a 0.0001 chance, like almost zero. It's essentially impossible that if it really was 50-50 that I would have got an 83 out of 124 breakdown. Okay, that's why a small p-value gives us the ability to reject the null hypothesis. If this is true, that's the probability that this happens. No, because right here we say 5% is the cutoff. All right, since the p-value of 0.001 is less than alpha, and again, none of this is for debates. That's written exactly like that with the numbers, the alpha and p-value, not p, because p is not what p-value is. So don't do that, okay? We reject the null hypothesis. There is convincing evidence that the couples prefer to kiss the quote-unquote right way. Or we have evidence, oh yeah, here's, I found the textbook. They said that the true population proportion is greater than 50%. The textbook just went this way and kind of explained it in general. If you're just trying to keep, to that like mantra, then you can put this answer down and that's fine. It does not matter. All right, so here we go. Let's go through the calculator. So we are going to get this on here. So we're going to go stat over to test. And it's one prop z-test. Again, if they use one proportion, we don't put that here, one sample. You're like, why don't they say the same? Texas Instruments and College Board are not the same organization. All right, P-naught. P-naught is going to be right there. Okay, you say, well, it doesn't say P-naught. But look, it is H-naught, or H sub 0, P sub 0. What was the null hypothesis saying P was? That's what that means right there. And then we had 83 out of 124. Okay, and then this right here, this gets a little bit confusing. Okay, the way that the textbook has it set up, we notice that the direction of this inequality sign always is the same as this one. So you're like, why are you always such a jerk on how we write stuff, IHS stats teachers? There's usually a reason for it. Pretty much always. So we need that see this is the prop. So this is what P really is, the proportion. We want to see if P is greater than P naught. And then you slide down to calculate. And then you will put the Z. So see here, I put the Z. The do step on this has two components that you must put. The Z value, and say, oh, but Z has that complicated formula. No, it's not. It's right there. And then it says P here, but that's P value. And again, that's College Board versus TI. College Board doesn't care what TI says, and vice versa. Okay, now see how that P that's 8.1 or whatever? That has to be less than 1. If it's bigger than 1, you need to look over and see this. Also, once you start getting e to the negative, you can typically put approximately 0, right? Because that's 1/100th of 1%. That's approximately 0. So you can do p-value, and do the squiggly equal sign and put 0 if you want. And then, oh yeah, we already did the conclusion. So that's how you do that one on the calculator. And again, you go back. We have another one we're going to practice here. You can go back and rewatch the video for the calculator. You got to get that calculator stuff figured out. It is truly amazing, all the work that calculator allows us to skip out on. All right, the next one is, this is also one that I find very interesting. They talk about fraud. So this AJL and Associates, they when they're auditing a company, one shows up more on expense reports as the first digit more than all the other digits. As a matter of fact, 30.1% of the time, 1 is the leading digit. And if you think about it like a lunch, if you're writing off, if you're putting an expense report down for a lunch, typically a lunch that that somebody would go to while they're auditing, they're not going to go to a fancy steakhouse, but they aren't going to McDonald's either, right? So it's probably going to cost somewhere between $10 and $20, $12, $17, $19. All those start with the 1. All the 3 digits, there's a lot more $100 expenses than there are $400 expenses. So this is what happened. And also another reason why I like this one, my sister and brother-in-law were both, are or have been audit accountants, and they use this. All the data is input into a giant spreadsheet essentially, and then this is the first thing they do. And if it's too far off, then it says right here, they will do a more thorough investigation of the company. So this is kind of like a pre-screen. And again, it has to be 30.1 exactly. The question is, what's the cutoff? Okay, so that's what we're going to do. So they found out that out of 300, 86 expenses started with the digit 1. So then they come and they say, all right, stats man, do we need to do a more thorough investigation or not? So P is the true proportion of expenses that begin with the digit 1. Make sure you define that properly. The null, always equal for the null. If you put something besides equal for the null, it's going to be really hard to grade the rest of yours, because what are you doing would be kind of my question. And then the alternate, not too many, not enough. It's that it's off. So we do not equals here. So make sure we pay attention to that. And say, well, how do I know which symbol to put in? And I don't like to say stuff that make me sound like a jerk, but here it is. Read the question. How do I know? Read the question. Everybody has the ability to read this question and tell, are they saying more, less, or not equal? So this one, it said, if it's significantly different, more or less. Y'all are smart enough for that. Don't even start with us on that one. All right, one sample Z test for P, not interval, test, right? And Z and P there. And again, make sure you get that all down right. A random sample was used. It just said a random sample. Maybe I could have said a random sample of 300 expenses. But again, all you're doing is saying random is important and it was satisfied within the problem. The 10% rule, we're going to assume there's more than 3,000 expenses to sample from. Again, a big company, that's not going to be an issue at all. That might be 3,000 expenses in a month, let alone a yearly audit. Or maybe a quarterly audit, whatever. That is not a leap of faith. And again, even if you're like, I don't think that's right, don't think about that. Just do it. Okay, that's not life advice. That's how we do this problem. Then we take the percentage times 300, 1 minus that percentage times 300. Both of these values need to be greater than or equal to 10. We need to expect 10 successes and 10 failures at least. Also, do not round these numbers. Well, okay, that might be rounded to a decimal place. Do not round them to whole numbers. They don't like that. because the idea is you're not understanding that it doesn't have to be a number that you could actually get. All right, and then again, we'll go through the calculator in a second, but we end up getting a p-value that's small. So since the p-value 0.005 is less than alpha, we reject the null hypothesis. There is evidence that they should do a more thorough investigation. Okay, so that's, again, pretty straightforward. Hopefully that made a lot of sense to you. And then here we go for calculator. So we'll go stat, over to test, one prop z-test. Okay, this time it's 0.031. Again, it says P naught. I don't have P naught here. Yes, but H naught. It's okay. That's what you do. And don't put P naught here. That's wrong. All right, and then we had, I lost my number, 86 out of 300. And this time it's the not equal. The not equal one's the nicest on this step because I don't have to decide, does it go this way? Which way does it point? It's not equal, we put not equal. Not bad, not bad at all. And then there's my Z. And again, round that to a couple decimal places. Again, exactly how it maybe did negative 2.81. That's fine. And then same thing, the p-value, I just cut it off. It seemed like a very logical place to cut it off with the double zeros behind the 5. Okay, they also give us p hat and don't need those, but there you go. Pretty nice. I'm telling you this right now. This function of the calculator is probably the most time-saving thing that there is in all technology. Well, at least for me, because I can't figure anything else out. All right, here we go. One other problem here. Now, this one is the express lane faster? So on this problem, what they're doing is two kids are going to go to the store and they purchase the exact same stuff. One goes to the express lane, one goes to the regular line, and they want to see if there's evidence that the express lane is faster. And this is a question close to my heart because in the self-checkout aisle, it always makes me nuts when people take 20 minutes to ring up 4 things. But it's not the self-checkout aisle, it's the express lane. And this problem's a little bit old right now. All right, so we have the express lane times and the regular line times. Also, to determine which lane each of them would use, they flipped a coin. That's important for the randomness. You still have to have some randomness going on here. And again, maybe why would that matter? Which girl went to which line? I don't know. Maybe one of them is more likely to know the person checking and they'll start talking and that'll make the checkout process last longer. So we don't know, we just randomize to make equal groups. Okay, on this one, we're trying to find out the difference between these two. So I'm gonna start off by defining D. Now this is not really part of the write-up. This is something that I do personally to establish the order that I'm going to do the regular time minus the express line time. Okay, so now I have mu of D, that's the variable I want, the true mean difference between the regular line and the express line. But I do know I'm going to do regular minus express because I've established that up here, and then I'm going to stay consistent with that. You could go the opposite. You could go express minus regular. The biggest difference, this would be a negative T. It would be the same number, but it would have a negative. These would be the same. What's going to happen is that the order of this needs to match up the sign of this T. And again, you don't really have to concern yourself with that. I'm just saying, if you're actually doing a write-up to prepare and you have one answer and your friend has the other and you switch the order, the only difference is you're going to have, this would be backwards. This arrow would point the other direction and this would be negative. Everything else stays the same. So there you go. I guess this one would be mirrored over 0. It would go further to the left than to the right as well. All right, so here we go. So the null hypothesis is that there is no difference. The alternate is that the difference is greater than 0. Now, we're trying to see right here, is there evidence that the express line is faster? Now, you got to be careful. This is time. Faster means less time. So then we need the regular minus the express to be greater than 0. So that's a little confusing as well. There are a lot of little traps on this problem that you could easily fall into. All right, and then we state our alpha. Okay, again, this is not technically part of the write-up. This is me telling myself and anybody else that's the order I'm doing the subtract in. But when I say the difference between regular and express, that's an algebraic translation to regular minus express. I personally like to write it out there. It helps me out. Okay, this one is different. This gets its own special name. This is a paired t-test for mu sub d. If we're doing the difference between two, and that's what we're actually measuring, it's going to be a paired t-test for mu sub d. And paired as in matched pair. And as you hopefully remember me saying 100 times, the College Board loves them some matched pair design. So I would say it's very likely you would see something to do with a problem like this because it's a matched pairs. All right, conditions. We flipped a coin to determine which girl would go to which line. Boom. 10% rule. Now, wait a minute. When we do a paired t-test, that's an experiment. This is a well-designed experiment, okay? We're not sampling. Now, I could understand if you count those up and say that's 14 times, we assume there's more 140 opportunities to go through the express and regular line or whatever, but we're not sampling. Remember, the 10% rule is to establish independent samples. There ain't any sampling, okay? Now, I went ahead and wrote this. You would just leave that blank. If you wanted to put what I have written here, I think that's fine. But if you ever see any of these on a College Board write-up, they always just skip it. It's just not on there. But I don't think they would count it. I'm sorry. There is no way they could count it wrong if you wrote this part out. And some of us, I get a little OCD sometimes. I just want to write stuff out the way it's supposed to be. Just boom, every time, just write it out. So there you go. It's your choice. The large counts. 15 is not greater than 30. Thumbs down on that one. That means we need to look at the sample distribution. Look at the samples distribution. So now it's, let's just go ahead and let's do the calculator now. All right. So I have these pre-typed in because it takes a little long to type all those in. So you can pause it and type those in, and then we'll continue with the problem. So now we need to get over here in L3, I need to get the differences. All right, also I have express in the first one, regular in the second one, I just typed them in right here. But remember, I'm doing regular minus express. So I'm gonna slide up so that I'm on the L3 cell, and I'm gonna type in L2 minus L1. Second 2, L2 minus second 1, L1. Then I push down, and it puts down the differences in all the times. 5 seconds, 248 seconds. What the heck was going on in that one? Minus 94. That time, the regular line was faster than the express line. Okay, that's what's going on in here. And you don't have to look at these individually. That's just the information we need. All right, now I want to see this box and whiskers or a box plot on my calculator. So I'm going to go second stat plot, go to the first one, turn it on, switch it to the box plot, and I need to make the X list L3. So I go down to L, and I switch that to L3. So it's probably as L1, so that's second one. If I want to switch it, I hit second 3, now it's L3. And then zoom 9. And there's my box plot. But notice you have to label and scale. So don't forget to do that. All right, and then let's go ahead and finish off this problem. We're gonna go stat, test, one prop z test. Okay, P naught is that the difference is 0. Oh, I'm sorry, I picked the wrong one. This is t-test. I'm really sorry about that. T-test. Now the good news is when I went to that wrong one, it was asking for stuff I don't have. So that helps me. Actually, if I was clever, I would have done that on purpose, but that was just a screw up there. But it wasn't all bad. So down here, we go stats or data. I want to be on data. I want to use that L3 data column. So I'm gonna use data. The null is 0, that's good. The list is L3, yours will not be at L3. I already did this once to practice to make sure I got the right answers. So yours would say L1, you need to switch it, hit second 2, and then again, The direction of this arrow is the same as the direction of this arrow. And that's probably not a very statistical way to explain it, but that will be successful for you. Okay. So on this one here, we need to give the t, I got that one. We need to give the p-value, which is that one, and then we need degrees of freedom. Okay, because this was more like a means problem. And actually it is means. I said this would all be the proportion problems, but this one's a means. Because I didn't say it's a percentage-wise, it was the actual numbers. So when we do that write-up, we have to put degrees of freedom. Now this time they don't give us degrees of freedom when we do the other problems for 9.3. It actually gives us the degrees of freedom. For this one, we have to remember to put that. Same thing, 3 things. First screw up, half. Second screw up, it's all wrong. Since the p-value of 0.0345 is less than 5%, we reject the null hypothesis. There is evidence that the express line is faster. All right.